Hey everybody, it's Mr. Wolf back with another video for the Unit 5. We're going to be moving on to trapezoids. Now this is the first thing you guys will see that isn't necessarily considered to be a parallelogram. We've been talking a lot about different parallelograms, but we'll get to that in a minute. Let's go ahead and start by defining some terms that you guys have seen already, but very vital that you remember for the test and whatnot. And remember, you can pause the video at any time to copy down what you need for your guided notes and make sure that you revisit the video when needed and all that good stuff, but I won't hold you up too long. Let's go ahead and jump in to the definitions here. So we have parallelograms. Now the base definition of parallelograms is polygon with parallel opposite sides. So the opposite sides, the sides across from each other, are parallel. We also know that those sides are also congruent. We know that the diagonals bisect one another. I'm just going to write diagonals bisect. And we also know that consecutive angles are... Oop, I almost wrote the wrong word there. Consecutive angles are supplementary. And there's a lot of other properties we've learned about stuff along the way, and that gets into these next definitions. For example, rectangles. Rectangles hold true to all of these parallelogram properties because guess what? A rectangle is a parallelogram whose diagonals are congruent and has 90-degree angles. Then we move on to rhombi, or rhombus, or rhombuses, whatever you want to say. Those are very similar to what we've been looking at, but they have 4 congruent sides. And their diagonals are perpendicular and bisect their interior angles. So let's remember that not only do the diagonals of a rhombi cross at a 90-degree angle because they are perpendicular, they also bisect the interior angles. And if you guys remember, all of these properties here that you see apply to the next one. So, all above. Remember, if you ever want to determine if a parallelogram is a square, you have to find a combination of rectangle and rhombi properties. And if it has one of these and one of these, then you know that it's a square. But today we're moving on to trapezoids. So what is special about a trapezoid? Now I really like this picture over here to the side, that this Venn diagram here. As you can see, the whole rectangle are quadrilaterals, meaning 4-sided polygons. And then you have this circle here that encompasses parallelograms. What do we have in there? Rhombi, squares, and rectangles. But what you'll notice is that squares falls in between rectangles and rhombi because, once again, a square is all 3. A square is a parallelogram, that is a rhombi, that is also a rectangle. Then out here, we have trapezoids all alone, because guess what? Trapezoids are not a parallelogram. Which is kind of interesting, because we've been talking all about parallelograms. Now you have a set of properties that are fresh and new and don't apply to each other like the ones we've looked at before. So let's go ahead and get into trapezoids. So a trapezoid is a polygon. I guess we could classify this further as a quadrilateral. With exactly one pair of parallel sides. So exactly one pair of parallel sides. If you look, it's this top side up here and this bottom side up here. Those are parallel, but it's easy to see that these sides, if extended, will eventually cross each other, negating any chance for them to be labeled as parallel. But there's some more information about what we have here. These parallel sides that you find on a trapezoid are what we call bases. So we'll call this one up here B1, this one down here B2. So the parallel sides, we'll repeat, are called bases. The other sides, we can call these legs. We'll say L1 and L2. So you have bases and legs. And there's some things we can say about this even further. For example, we call these angles down here the ones between, well, the ones that connect to the bases, I should say, are called base angles. So you have your base sides, your legs, and then you have your base angles. I hope all of this makes sense. But remember all these terms and how you label these, because this falls in. This falls into very much important for solving problems and whatnot with trapezoids. Before we move on, I guess we should touch on another trapezoid property here. Is that what I like to call the leg angles are supplementary. And when I say the leg angles, this isn't necessarily a technical term, but I mean these set of angles here. The angles from base 1 and leg 2 to base 2 and leg 2, and then the one from base 1 and leg 1 to base 2 and leg 1. So this one here, and this one here, and then this one with this one. Supplementary. What's that mean? They add to 180 degrees. All right. Let's move on. So a trapezoid has this segment you sometimes see, you'll see actually a lot, that connects the two midpoints of its legs. So E would be the midpoint of AD, and F would be the midpoint of CB. So E is midpoint of AD, and F is midpoint of BC. And we call this segment the median. So the median of a trapezoid is the line segment that connects the two midpoints of the legs. Not the bases, the legs. So you're always going to see it coming somewhat horizontally, depending, I guess this depends on the orientation. But remember, it's going to connect to those legs, which are the ones that are not parallel. Some more information on the median. The length of the median is always going to fall in between the lengths of the bases. And this makes sense when we look at it. As you can see, if we call the top one up here base 1 and the bottom one base 2, you can see that the legs come down in a slant. And the farther those legs come down, the bigger the line segment that from side to side would be. So the length of the median is always going to fall in between the lengths of base 1 and base 2. In fact, it is the average. So the length of the median is the average of the base lengths. Now, what does average mean? What's another word we use for average? Oops. Mean. We say the mean of something, you add it up and divide by the amount there. So let's say that in order to find the median of a trapezoid, you get base 1 length plus base 2, divide that by 2. Or base 1 plus base 2, well, I could help if I wrote a 2 there, times 1/2. Either of these work, but in order to find the median length, you need to know that the median length is the average of the base lengths, meaning you can add them together and divide by 2, or you can add them together and multiply by 1/2. So let's look here. If the line segment AB equals X, label that, and the line segment DC equals 3X, what is the median length? So we're looking for EF. We want EF. Well, let's use the information we just had. We said if we add the two base lengths together, getting us 4X, we add those two base lengths together and divide by 2, we get our answer. The 3X plus X is going to be 4X, and we divide that by 2, and that's going to leave us with 2X. So, EF equals 2X. Now, you'll run into problems like this where you're given one side a numerical value and the other one with an unknown, and you can solve for that X, but this is just kind of a bland, not necessarily bland, but a simple example of what you will see on this sort of thing. So just remember that formula. Remember, base 1 plus base 2 divided by 2, or base 1 plus base 2 in parentheses times 1/2. So what to know about medians? So the median is the segment that joins the midpoint of legs on a trapezoid, of course. It is parallel to both bases. Its value always falls in between the values of the bases, but even more specifically, its length is the average of the base lengths. Remember this. This is very important. Very important. The median is one of those things that you will be quizzed on a lot when it comes to activities, the test, and whatnot. So make sure you know everything on this checklist by heart. So now, we're moving on to the isosceles trapezoid. And it's very easy, and I noticed myself doing this when typing all this up, to accidentally say isosceles triangle, which is almost a good thing because you really kind of want to think of this like an isosceles triangle. So think about isosceles triangle. What is special about an isosceles triangle? Well, an isosceles triangle has two legs there that are the same length, right? It would look something like this, where this base side on the bottom is not the same length, but these two are. These two sides are congruent. And then from that, we could say, well, this angle is congruent to this angle. You guys remember that? I hope you remember that. I asked you a question as if you could respond. Anyway, so things to do when it comes to isosceles trapezoid is think about the isosceles triangle because the same properties are kind of applicable here. What we'll say is both legs are congruent. So the legs are congruent. That's an important one. Just like an isosceles triangle, an isosceles trapezoid has congruent legs. Now, just like the angles of an isosceles triangle, we can say that the base angles of an isosceles trapezoid are congruent. are this. Base angles congruent. So the legs are congruent and the base angles are congruent. Keep this in mind, because the isosceles trapezoid is a very special trapezoid. We'll talk about it some more. So, given angle D, so this angle down here, is equal to 16x plus 2, and angle C over here is equal to 20x minus 10. What is the value of x? Well, let's think about what we just said. We just said that the base angles are congruent. And what's congruent mean? Equal, right? So in this case, we can say that 16x plus 2 is going to be equal to 20x minus 10. And then some basic math here. Let's add 10 to both sides. You get 16x plus 12 equals 20x. Then let's subtract this 16x to get x's all on one side. Then we're left with 12 equals 4x. And then we want to get that x by itself, so the last step we do is divide by 4. And we're left with 3 being equal to x. And then with this, you can plug your x back into the 20x minus 10, and the 16x plus 2 to get to your angle measures. And you'll realize these equal the same thing. So given angle C equals 9x, angle B equals 13x plus 4, what is the value of x? Now this one you have to recall back on what we've said near the beginning. What do we know about these two angles? I called them the leg angles, although that's more of just a general phrasing, not necessarily a definite term. But the angles here, we said that they are supplementary, right? So if those angles are supplementary, we know that they add to equal 180. So 13x plus 4 plus 9x equals 180 degrees. So what do we do from here, right? What do? We add our 13 and our 9. That gets us 22x plus 4 equals 180. We subtract our 4 from both sides. Leaves us with 176 degrees. And just some quick mental calculations or calculator, whatever you use here, you'll learn that 176 over 22 is going to equal your x. Well, that simplifies down 8. So we can say here that if we know these two angles equal these things, 13x plus 4 is angle B and 9x is angle C, we can find the x value of 8. And then, once again, you can plug your 8 back in and find the measures of those angles. And once you do this, we know that the base angles are congruent. So once you find these two out, you'll know what all 4 of the angles measure to. Hope that makes sense to everybody. If not, rewind and watch again, because I feel like this is a really good example for you guys, one that you'll definitely see something like on the test. So let's talk about the diagonals of an isosceles triangle. I know you guys have heard probably what you think is enough about diagonals, but there's special properties for diagonals of all polygons, and the isosceles trapezoid is yet another with its own little bit of information you guys need to know. So the isosceles triangle, not triangle, I even wrote it here. Guys, this is how easy it is to do this. Don't make the mistakes I have. The isosceles trapezoid, pretend that didn't happen. The isosceles trapezoid diagonals have equal lengths. So the diagonals are congruent. Diagonals are congruent. Pretty simple, right? Reminds you of what other polygon? Which one of the parallelograms was it that had diagonals that were congruent? Starts with an R. Rectangle, right? The rectangle has congruent diagonals, and similar to the rectangle, the isosceles trapezoid has congruent diagonals. And that's really the only big one to remember here. So you guys are in luck. You don't have a major list of properties for there. So what to know about isosceles trapezoid? Legs are congruent. Its base angles are congruent. And the diagonals are congruent. And if you go through and you write down all these properties and you understand each of these properties from each slide, you're going to be looking good for this section of the test. This seems like a lot of information about one shape. We did write a lot down, but in the end, there's a pattern you can kind of follow. And one last thing before we wrap up the video, if you guys could do me a favor, this is just a little test here. I want everybody who watches to this point, make sure like at the bottom of your note sheet somewhere, just sign your name. You don't have to sign it like this, but just write your name at the bottom of your note sheet somewhere underneath the last question, just to give me an idea of who's actually listened this far into the video. Anyway, guys, I hope this helped. If you have any questions, make sure to email me, email Mr. Rose, get on the Google Meets. Don't be afraid to ask questions in class, and make sure you're staying on top of this stuff, guys. This unit is coming to a close. This is the last content video. We're going into review mode now for the test. So make sure you're caught up on everything, because remember, everything is due midnight the day of the test. Stay on top of it, guys. It's very important to keep your grades up this term. And I hope you guys have a great day, and thanks for watching.